Hi, welcome to a special video on separating mixtures using polarity, in particular how we use paper chromatography. So what is chromatography? It is a technique for separating components or solutes of a mixture on the basis of polarity. This is achieved by using a moving fluid stream, which is called the mobile phase, and a contiguous stationary phase. The mobile phase may be either a liquid or gas, while the stationary phase is either a solid or a liquid. And this is the definition I got from this dictionary here. So in particular, we're going to talk about paper chromatography. The stationary phase in this case is paper. Sometimes it's little strips of white paper. And the mobile phase would be your solvent. So here's the setup. So first you take your plate or your paper and you have your solvent in a beaker and you put a dot of your solute on the piece of paper, and you want to mark where your starting point is, and we call that the origin. Then as the solvent wicks up the paper or the plate, it'll start to separate your mixture into components A and B. At the end, you want to mark where the solvent ended, and this is called the solvent front. Okay, so when setting up the system, you have to know what you're using. You have to know the polarity of the stationary phase. So your paper, is it polar or nonpolar? And of the mobile phase, is your solvent polar or nonpolar? Because there are two forces that are occurring. One, there's the solubility of your dot or your solute in the mobile phase. The component that is more soluble, i.e. attracted to the mobile phase, will move up the paper faster. So in this case, that's the blue dot. And then there's the attraction to the stationary phase, which is the paper. Okay, the component that is more attracted to the stationary phase will move up the paper slower. In this case, it's the red dot. So there's two things going on. Your solute is attracted to the paper or to the solvent. And it's going to, if it's attracted to the paper, it's going to move slower. If it's attracted to the solvent, it'll move faster. So how do we actually quantify this with a number? We calculate something called the retention factor. And the retention factor is the amount of each component in a mixture, how much it travels, and we quantify it using this RF value. The retention factor of a particular material is the ratio of the distance the spot moved above the origin to the distance the solvent moved above the origin. So how do we calculate this retention factor? First, you need to mark your origin. So I said the origin is where you're starting. So this would be the origin right here. Here's the origin. Then at the end, you have to mark where the solvent stopped. That would be your solvent front. And you calculate RF by taking the distance traveled by your solute, which would be your dot in this case, divided by the distance traveled by the solvent. The solvent distance should always be the largest number. Okay, so let's do it for the blue dot. So we see the solvent traveled 10 centimeters, and that's going to go on the bottom, and the blue dot traveled 8. So its RF value is 0.8. And let's do the same thing for the red dot. See, the red dot traveled 0.2 over 10. So 2 over 10, so its RF value is 0.2. The higher the RF value, the greater the attraction to the mobile phase, okay? I spelled this wrong. RF can range from 0 to 1, okay? Because the highest distance should always be the solvent. So let's do a sample problem. If we use polar paper, so we're saying the paper is polar, and benzene as our solvent. Benzene is nonpolar. Okay? Rank the colors from low to high polarity. So the solvent is nonpolar, which means the highest dot here is the most nonpolar substance. So it would have the lowest polarity. So it would be blue, and then purple, and then red. And you could actually calculate the RF values for this and rank it that way, but we could just visually see it right here. And that is the end of our special presentation on chromatography.